Today we are doing lesson 3.1, simplifying algebraic expressions. Our I can statements for today: I can use properties of operations to simplify algebraic expressions, and I can solve real-life problems involving expressions. So before we get into our problems for today, I want to start by just kind of giving you a visual for finding and combining like terms, which is really the skill that we're doing today. So if I had an expression like, let me get my pen here. Let's say I had 2x plus 3y plus x plus 2y. That's called an algebraic expression. It doesn't have an equal sign, so it's not an equation, and we can't solve it to find out what x or y is without that equal sign, but we can simplify it to kind of give us a better idea of what exactly we have there. So our variables here stand for numbers that we don't know, and you can think of them as different shapes. So I have some letters over here, or objects over here, that I am going to pull to represent my expression. So for x, 2x means I have two of them. So here are my two x's. 3y means I have three of those. 1, 2, and 3. Okay, plus x just means 1. So if there isn't a number in front, and that number is called a coefficient. So if there isn't a number in front, that just means 1x. And then 2 more y's. Okay, so since my x's and y's are different letters, that's why I've got them there as different shapes. Combining like terms means looking for the same shape, same variable, and it also has to have the same exponent. Over here, I have this cube that says x squared on it. It kind of looks like the square, but it's not the same shape, and that's because there's an exponent here. Okay, so I've got, if I move them so that the same letters are with each other, my simplified expression over here, oops, I got to change back to a pen. My simplified expression is going to be 3x plus 5y. I have 3 x's and 5 y's there. Now if I added an extra, actually here, I'm going to just erase this. I'm going to write something new. Okay. So here's my new expression. I'm going to go ahead and just start with what I already have out. 3x plus 5y plus 2x squared plus another x. Okay, so here now I have one that has an x squared on it. That square tells me the x is actually a different shape. It's this cube here in my little picture. I have 2 of them, 1, 2, and then I have one more regular x. So when I combine my like terms and simplify that expression, I can take my x, bring it down over here, and then I can count up how many total I have. So my simplified expression for that one would be 4x plus 5y plus 2x squared. Like terms have the same variable and the same exponent. All right, so here's a demonstration of some of the words that you just heard me say. Coefficient is the number that goes in the front. Variable is the letter that comes after it. If you have just a variable and no coefficient, that means one of that thing. Terms are variables or other numbers without a variable. Those are called constants, so variables or constants, and then they're separated with addition or subtraction. So 7x is a term, 5 is a term, and then this minus sign is considered part of your term, because if we did, whoa, there we go, boom, boom, and we did plus negative 3y squared, that's really a negative value. So when I'm finding my terms, I have to change everything to addition, and that way it makes it a little easier to see. When I'm subtracting a term, it's really like adding a negative value. And then sometimes you'll see division. It's kind of rare, but occasionally you will. X divided by 3 is also considered a term. Like terms have the same variable and the same exponents. Constants, which have no letter, are also like terms. So for example here, like terms 3x and 2x, they both have the letter x. Unlike terms 5x squared and 2x, they have x's, but the exponents are different. Here I have w and w divided by 7. Those are like terms. They both have the w with no exponent on it. And then here, 6a and 6b, those are not like terms because the coefficients are the same and not the variable. The variable has to be the same and the exponent for like terms. And then on our last column here, 5 and 1 and 8/10, those are like terms. They're both constants. They are just numbers by themselves without a variable. And 3 and 2/10 and n are not like terms because 1 is a constant and 1 is a variable. Like terms, you have to have the same variable and the same exponent. All right, so let's try some problems. This first one says identify the terms and like terms in each expression. So you have to actually list them out. So terms and like terms. The first step on doing these problems is to do boom, boom, and make things plus negative. So boom, change to addition, boom, change the sign, boom, change to addition, boom, change the sign. So any subtraction we need to change to addition. It's just going to help us see our terms. Now I'm going to rewrite this list, and where there's an addition sign, I'm going to write a comma. I am going to make sure I include those negative signs. Okay, so my terms for this first one, 9x, comma, -2, comma, 7, comma, -x. Those are the terms. Now I need to do the like terms. Like terms have the same exponent and the same variable. All right, so like terms, let's see. I have 9x and -x. They both have an x. And then I have -2 and 7. Those are both constants. Okay, let's take a look at B. Z squared plus 5z minus 3c squared plus c. So again, I'm going to do boom, change to addition, boom, change the sign. I'm going to start with my list of terms. All right, z squared, comma, 5z, comma, I'm putting the commas where the plus signs are, -3z squared, and z. Then I need to do the like terms. Yes, you need to do both lists. That's what the directions say. Okay, same variable, same exponent. So z squared and -3z squared. And then we have 5z and z. All right, and then our next type of problem asks us to simplify. And really what that means is you need to find and combine the like terms. It's putting those terms into groups together like we did when I showed you the different shapes. So here's the expression 3/4 y plus 12 minus 1/2 y minus 6. So I'm going to do boom, change to addition, boom, change the sign, boom, change to addition, boom, change the sign. Okay, so now I have 3/4 y plus -1/2 y plus 12 plus -6. So I use the commutative property here to rearrange them so that the like terms are together. And I'm going to go ahead and use the associative property as well to group them. That way it makes it really easy for me to see what I have to add. Okay, so now I have 3/4 and -1/2. I have a fraction in there, which means I need to find a common denominator. I'm going to use fourths. So 3/4 y will still stay 3/4 y, but -1/2 we're going to do times 2 times 2, and that's going to become -2/4 y. And then I have plus 12 plus -6. Okay, same signs, find the sum, different signs, find the difference. Here I have different signs, one positive, one negative, so I'm going to subtract. I'm going to get 1/4 y. More positives, answer's positive. Plus, I'm going to come over and look at my second set of parentheses. 12 plus -6, different signs, find the difference. I'm going to do 12 minus 6, which is 6. So my simplified expression is 1/4 y plus 6. I could have written it in the other order. 6 plus 1/4 y would mean the same thing. All right, go ahead and pause the video and try these 4 on your own. Okay, let's check our answers. So for number 1, you needed to list the terms and the like terms. So terms, I need to just start by doing boom, boom, make that a plus negative. So my terms here are y, comma, 10, comma, -3/2 y. I changed everything to addition, and then I just replaced the addition signs with commas. Okay, so my like terms. I have y and -3/2 y. Same variable, same exponent. I don't have any like terms for the 10. All right, number 2, 2r² plus 7r minus r² minus 9. Boom, change to addition. Boom, change the sign. Boom, change to addition. Boom, change the sign. All right, I'm going to start with my terms. 2r² plus -r². Oops. I'm rewriting the problem here. Got so excited about doing this math, I was starting to combine my like terms instead of just listing the terms. I need to keep the order the same and just replace those addition signs with commas. All right, 2r², comma, 7r, comma, -r², comma, -9. Okay, now I'm going to find my like terms. I've got 2r² and -r². And then that's it. I don't have any other like terms. So I guess I'm going to get rid of this comma. I don't really need it. All right, let's take a look at our next one. So simplify the expression. I have 14 minus 3z plus 8 plus z. So boom, change to addition. Boom, change the sign. I'm now going to change the order here. So I'm going to use commutative property. I generally like to put my variables first, but it doesn't matter. -3z plus z plus 14 plus 8. So I used my commutative property here. I'm going to go ahead and put in some parentheses. I've got my like terms grouped. Okay, -3z plus z. Different signs, find the difference. Remember, the z by itself is like 1. Some people like to actually write the 1 in there. Ooh, that's a little sloppy to read. Let me rewrite that for you so it doesn't look like an h and a z. You don't have to write in the positive one, but you can. So here, I'll rewrite it plus 1z. Okay, so -3 plus +1 is -2. So that's going to be a -2z. And then 14 plus 8 is going to give us 22. So that is my simplified expression, -2z plus 22. Let's go ahead and take a look at our next one. 3/8 b minus 3/4 b. So I'll do boom, change to addition, boom, change the sign. I need a common denominator, so I've got 8s here and 4ths. I'm going to do times 2 and make those 4ths into 8s. So 3/8 b plus -6/8 b. Okay. I have different signs. I'm going to find the difference. So I'm doing 6 minus 3 is 3. It's going to be a negative because I have more negatives than positive. Denominator stays the same, -3/8. B is my simplified expression for that one. All right, next thing we're going to talk about is distributive property and looking at expressions containing distributive property. So here I have a situation where I'm doing some baking, and I've got eggs and boxes of cake mix and teaspoons of oil. So it says E plus B plus T, so I'm up here, this part, represents the ingredients for cake batter, where E is the number of eggs, B is the number of cake mix boxes, and T is the number of teaspoons of oil. So for one recipe, and they put a 1 out here in front of the parentheses, we need 3 eggs, 1 box of cake mix, and 2 teaspoons of oil. Okay, so that's what my different variables are standing for. My eggs are 3, box is 1, teaspoon is 2. Okay. So that is my single batch. So now I'm going to go ahead and take a look at making double the batch. Okay, so 2 single batches. I need 2 sets of 3 eggs. That's going to give me 6 eggs. We're taking this 2 and we're multiplying it times each thing. I can't just say I need 6 eggs, but I can still have 1 box of cake mix and 2 teaspoons of oil and still have it taste right. If I have to double the eggs when I'm doubling the recipe, I have to double everything. Otherwise, my cake isn't going to turn out. So I did 2 times the 3 to get the 6. I'm going to do 2 times the 1. And that's going to tell me I'm going to need 2 boxes of cake mix for my 2 cakes. That makes sense. And then I'm going to take the 2 times the 2. So for my teaspoons of oil, I need 4. So my eggs are going to be 6. My boxes are going to be 2. And my tablespoons are going to be 4. All right. So distributing is taking that number in front and multiplying it by everything inside the parentheses. So I guess I'll write that down here. So multiplying number in front of parentheses by everything inside. All right. So it says write an expression with parentheses that represents a triple batch and distribute to show the total quantities. Triple means 3 times, so I'm going to have my 3 in the front. And then now instead of drawing the little pictures, I'm going to use the letters E, B, and T. So my recipe, remember, was 3 eggs, so 3 times 3 E, plus my 1 box. So I'm just going to write B. I could have written 1B, but I'm just going to write B, plus 2 teaspoons. That's my expression for a triple batch. Now I'm going to use distributive property. I'm going to multiply times everything inside that parentheses. Okay, so now I'm ready to multiply. Let's see, I guess I'll write it over here. Okay, 3 times 3 E would be 9E, 9 eggs, plus 3 times B is 3B, 3 boxes, plus, and then 3 times 2 is 6, so I would need 6 teaspoons of oil. All right, so distributive property. If you look in the book, they use letters like that to stand for A in front of parentheses times the quantity B plus C. I can multiply A times B and then add it to A times C. It means the same thing. All right, it says next we are preparing a recipe that requires 5 frozen bananas per batch, plus an unknown amount of chocolate. We're going to call it X. Write an expression with parentheses that represents quadruple recipe. Quadruple recipe means 4 batches. Okay, so going back up here, we have 5 frozen bananas. So I'm going to write 5B for the 5 bananas. And then X is our chocolate. They told us to use the letter X for that. So 5 bananas plus X amount of chocolate for each recipe. And then I need 4 times that. Okay, so this is going to work for any value for X. All right, so now we're going to simplify our expression. We're going to write the expression for the quadruple batch in the bowl. So 4 groups of 5 bananas is going to give me 20 bananas that I need for this quadruple batch. and then 4 groups of X amount of chocolate. I don't know how much that is, but 4 times our X. Okay, so that's how much I need. I need 20 bananas, 4 groups of whatever the amount of chocolate is in order to make my 4 chocolate frozen bananas. Okay, and then over here on the side it says, note, when distributing a negative, we multiply by -1. So, so we're multiplying by -1 when we just have that negative out in the front. Okay, so distributing the negative, -2 times the quantity x minus 5. All right, since I know I'm multiplying by negative and I have a minus sign in here, I'm just going to go ahead and do boom, boom, make that plus -5. -2 times x is -2x. -2 times -5 is a positive 10. The signs on my answer changed. My x was originally positive and it became negative. And my 5 was a negative and it became positive because I multiplied by a negative. And remember, with negatives, same sign positive, different signs negative. All right, so here I've got a negative or a minus sign right in front of it. And it doesn't have any number, so I can just write in that invisible 1. So I'm just going to write it right there, -1. And now I'm going to distribute that -1 times each part. -1 times 4e is -4e. It's just changing the sign. Plus -1 times 3 is -3. So that's my answer on that one, -4e plus -3. All right, so let's look at our next one. Okay, simplify -1/2 times the quantity 6n plus 4 plus 2n. Okay, so I'm going to do distributive property first. Now, with order of operations, parentheses comes first, but I don't have any like terms within those parentheses, so I've got to get rid of them. I'm going to do my multiplication. Multiplying by 1/2 is like dividing by 2. I'm just going to write divided by, really that's negative, so it's like dividing by -2. But I'll show the multiplication off to the side just so you can kind of see why that works. Okay, -1/2 times 6n. So -1/2, if we're doing fraction multiplication, we need to change our whole number into an improper fraction. And then I like to cross cancel. So 2 divided by 2 is 1, and 6 divided by 2 is 3. -1 times -3 is -3. 1 times 1 is 1. -3 over 1 is -3. So when I do -1/2 times 6n, I get -3n. It's like doing 6 divided by 2. Different signs, answers negative. Plus, now I'm doing -1/2 times 4. Again, for those of you that need to see it, I'll write it over here. I won't cross cancel on this one just for the people that don't like to cross cancel. So I'll multiply straight across. When 1 times 4 is 4, it's negative because we have different signs. 2 times 1 is 2. -4 over 2 simplifies to -2. So here, -1/2 times 4 is -2. Then I have this plus 2n on the end. Okay, so now that I've done that, I'm ready to find and combine my like terms. So I'm going to use commutative property. I'm going to rearrange it. -3n plus 2n plus -2. I don't really need parentheses here, but I like to do it just to kind of indicate where my like terms are. -3 plus +2 is a -1. I'm just going to write -n plus a -2. You can also write it without the plus in there and just write -n minus 2. The book will never write answers as a plus negative. They will only ever write it as a minus, but it means the same thing, -2 and plus -2. That's the same thing. So you could write it either way. I don't have a preference about how you write your answers. Okay, here are 2 more to try on your own. So go ahead and pause the video and try these 2. Okay, let's check our answers. So for number 5, I have 3 times q and 3 times 1. 3 times q is 3q. 3 times 1 is 3. Minus 4. going to go ahead and do boom, boom, make that a -4. Use my associative property and group those. Those are my like terms. So I get 3q plus -1. -4 plus +3 is -1. Or instead of a plus negative, I could have also written 3q minus 1. Means the same thing. You can write it either way. All right, this next one has fractions, but don't let those scare you. Boom, boom, that's a -4 that we're distributing. Boom, boom, that is like a -1/4. I'm going to do my multiplication off to the side. I'm going to make that a -4 over 1. -4 over 1 times 3/4. I put it over 1 because we're multiplying by a fraction over here. All right, I'll do this one with cross-canceling. 4 divided by 4 is 1. 4 divided by 4 is 1. That one's -1 since that was a negative. -1 times 3 is -3. 1 times 1 is 1. -3 over 1 means the same thing as -3. So I have 7 plus -3x. I can't forget about that x that's there. Plus. And now I'm going to do -4 times -1/4. -4 over 1 times -1/4. This time I won't cross cancel for those people that don't like to cross cancel. -4 times -1 is +4. Same signs, answer is positive. 4 times 1 is 4. 4 over 4 is 1. So I have a +1 here. Now I'm going to use commutative property, put those like terms together. The 7 and the 1 are my like terms on this one. 7 plus 1 is 8. So I have 8 plus a -3x, or you could write it as 8 minus 3x. I said before, I generally like to put my variables first. I happen not to on this one. It doesn't really matter. But I could have written -3x plus 8, and it would have meant the same thing as well. Let's take a look at a story problem. So it says each person in a group buys a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies and interpret the expression. So they're asking us to do two things. One, we've got to write an expression and simplify it. And two, we need to interpret, which means to explain. Explain what it means for this situation. Okay, so we're going to start by writing the expression. We don't know how many people we have. Each person. I'm just going to use the letter P to stand for each person. Okay, buys a ticket, a medium drink, and a large popcorn. Okay, so the tickets are $7.50. So $7.50 per person plus, and then let's see, a medium drink, if we go back down to the table, that's $2.75 per person. And then for the large popcorn, let's see, that's $4 a person. Okay, all of those are like terms, and I need to combine them. So I'm going to forget about my variables for a moment. I'm going to line up my decimal points. And then I'm going to add. All right, I'm going to go ahead and just do them all in one addition problem. 0 plus 5 plus 0 is 5. 5 plus 7 is 12, plus 0 is still 12. Got to bring down that decimal. I'm going to carry my 1. 1 plus 7 is 8, plus 2 is 10, plus 4 is 14. Now I'm going to put that expression, that label there, P. Okay, now I need to label it as a story problem, so I'm going to put in dollars. Okay, so I did number 1. There's my expression. I've got a label on it, $14.25 P. Okay, so what does that mean for this story? That means each person will spend $14.25. Okay, so all of that was lesson 3.1. We're actually doing the extension for 3.2 as well, because it is looking at factoring, which is basically the opposite of distributive factor, doing the distributive property, sorry. And so since they're really closely related, we're just going to combine them in the same video here. So factoring, here's our steps. 1, find the greatest common factor and put it in front of the parentheses. 2, divide terms by greatest common factor and put them in the parentheses. And then 3, operation in the parentheses is going to stay the same unless your greatest common factor is a negative. All right, so let's try this one. So for the first one, 12x and 18. Greatest common factor. I need to list out what are numbers that would divide evenly into both 12 and 18. So you can do this mentally. I'll list it out just for this one for anybody who would like to see it. So 12. I know that 1 times 12 equals 12. I know that 2 times 6 equals 12. I know 3 times 4 equals 12. I know 5 doesn't multiply times anything to equal 12, and I've already hit 6. So, okay, that's all the factors of 12. Now I'm going to do the same thing for 18. So I have 1 and 18 equal 18. 2 times 9. 3 times 6. See, 4 doesn't go into 18 evenly. 5 doesn't go into 18 evenly. And then 6. Okay, so we've got all the factors. Now we're looking for the greatest common factor, the largest one in both lists, and that would be 6. That's the number that goes in front of the parentheses. 6 times. Then we're going to divide. 12x divided by 6 is 2x. Answer here, or the operation is going to stay plus. And then 18 divided by 6 is 3. If I wanted to check my answer, then I could use distributive property to see if I get back to my original problem. So let's try it. 6 times 2x is 12x. 6 times 3 is 18. So that's factoring using the greatest common factor. All right, let's look at this one. Here I have a negative 4. If I have a negative coefficient, I'm going to use my negative coefficient there as my factor, what I'm going to divide by. 4 does go into 24 evenly. So on this one, I don't even really need to list it out. Negative 4 is going to go on the front. Okay, negative 4x divided by negative 4 is x. Anything divided by itself equals 1. All right, plus 24 divided by negative 4 is negative 6. Now, I said above that if you factor by negative, your operation changes. And it could. If you wanted to write it this way, it would mean the same thing, negative 4x minus 6. That's because minus 6 and plus negative 6 mean the same thing. Negative 4 times x is negative 4x. Negative 4 times negative 6 is positive 24. So when you're dividing by a negative, your sign's changing here. It either needs to be a plus negative or it needs to change to a minus sign. All right, and the last one. Here, when you have fraction ones, the directions won't say find the greatest common factor. The directions will say to factor the coefficient. So the coefficient here is 1/2. That's what's going to go on the outside of our parentheses, 1/2. Then we divide each one of these things by 1/2 to figure out what goes on the inside. So 1/2 x divided by 1/2 is x. Anything divided by itself equals 1. I'm going to move that minus sign down. Okay, now I have a 1/4 that I need to divide by 1/2. The number in front of the parentheses goes second in our problem. Okay, we're ready to keep change flips. So 1/4 times 2 over 1. Let's see, I'll just multiply straight across. 1 times 2 is 2. 4 times 1 is 4. 2/4 simplifies to 1/2. If you can simplify fractions, you always want to do that. And then I'm ready to put my answer back in. 1/2 x is 1/2 x. 1/2 times -1/2 is -1/4. And if you wanted to do boom, boom, make that a plus -1/4, then you certainly could. You always want to make sure you're using the distributive property to check your answer. Okay, last one. So matching the algebraic expression on the left with its factored form on the right. Go ahead and pause the video and try this one on your own. All right, let's go ahead and check our answer. Okay, so for number 1, I've got 12x plus 6. Largest number that can go into both 12 and 6 is 6. That's going to go on the outside of the parentheses. 12x divided by 6 is 2x. You can think about that as being like the 12 squares split into 6 groups, or 2 squares. And then 6 divided by 6 is 1. 6 times 2x is 12x. 6 times 1 is 6. Okay, so it looks like this one is going to match with C. All right, let's try this next one, 12x and 6. So again, we have 6 as our greatest common factor. 12x divided by 6 is 2x. We're going to keep the operation the same, minus. 6 divided by 6 is 1. So now I have 6 times the quantity 2x minus 1. So that looks like that's over here, B. For number 3, here I have a negative. And again, if you have a negative coefficient, they're going to ask you to have a negative in front of the parentheses. So this time instead of 6, I'm going to write -6. -12 divided by -6 is a +2. So +2x. If I did this, boom, boom, made that plus -6, a -6 times a -6 would be a +6. I have a negative number on the outside here, so my operation switched. So -6 times the quantity 2x plus, not plus 6. Well, let's fix that. That's going to be +1. I forgot to divide. -6 divided by -6 is a +1. So it looks like that one's going to match up with D. And then my last one, again, I've got a negative coefficient with my variable, so I'm going to have a negative number in front of my parentheses. -12x divided by -6 is 2x plus, and then -6 divided by, +6 divided by -6 is a -1. 2x plus -1 means the same thing as 2x minus 1, which is how it's written up here for A.